Session 2, Types of Systems, Open and Closed. So in the previous session we have discussed the basic concepts of thermodynamics. In this system we'll discuss about the types of system. So here the introduction, there are mainly three types of system. One is open system, closed system and isolated system. In the open system, there is a chance for the exchange of both energy and matter with its surroundings, and hence can undergo change of composition. Whereas in the closed system, there is an exchange of energy but not the matter with its surroundings. Isolated systems exchanges neither the matter nor energy with its surrounding. So these are the examples of a open, closed and isolated system. Closed system, a fixed amount of mass and no mass can cross its boundaries. For example, a vessel with water, heating water placed on which the vessel is placed with a cap or a lid. So here there is an exchange of heat energy but not there is exchange of a mass. So the mass is constant but the energy varies. Open system, that is with control volume, a properly selected region in space. It usually encloses a device that involves mass flow such as compressor, turbine or nozzle. Both mass and energy can cross the boundary of a control volume at a constant rate. Control surface, the boundaries of a control volume, it can be either real or imaginary. So water heater is an example of a open system with controlled volume. So here the imaginary boundary, there are two boundaries here, the imaginary boundary as well as the real boundary. So here and the water flows as there is a cold water, the example here is a water heater in which the cold water is entering at a inlet through the nozzle, and here at the nozzle there are two boundaries, one is the real boundary and the other one is imaginary boundary between the hot and cold water. So here the control surface and the hot water that has been transferred is removed through the outlet portion. So there is a description, types of boundary and interactions. In the open boundary, all the interactions are possible. The closed boundary, matter cannot enter or leave. In semi-permeable, only certain species can enter or leave. Insulated, heat cannot enter or leave. Rigid, mechanical work cannot be done. Isolated, no interactions are possible. So again there are another type of discrimination or classification of systems, that is homogeneous system and the heterogeneous system. In the homogeneous system, properties are the same throughout or the properties vary smoothly without showing any surface of discontinuity. Example, liquid water in a beaker or column of dust-free air above the Earth's surface. Heterogeneous system, it consists of two or more distinct homogeneous regions or phases which causes a sudden change in the properties at the phase boundary. Example, a liquid mixture of benzene and water and water vapor in a closed container. The next one is process. A process is defined as a change that takes place within the system and is referred to as the process. The process occurs when there exists a driving force for change or a state between the parts of the system or between the system and surroundings. There are two types of processes. One is reversible process and the other one is irreversible process. In the reversible process, the system is closed to equilibrium at all times. Hence, there are infinitesimal alterations of the conditions can restore the universe, that is to the original state. In the irreversible process, finite alterations of the conditions that can't restore the universe to the original state. Examples of various processes. First one is isothermal process. The process takes place at constant temperature. Examples of freezing of water to ice at -10 degrees centigrade. Isobaric process, that is the process taking place at constant pressure, that is heating of water in open air under atmospheric pressure. Isochoric or isometric process that occurs at constant volume, that is example is heating of gas in a sealed metal container. Cyclic process, the final and the initial state are the same, however the heat and the work done we need to be zero. Adiabatic process is a change in heat, that is dq is nothing but a change in heat is zero during the process, that is no heat is added or removed from the system or to the system. Heat does not enter or leave the system concerned. The adiabatic expansion of a perfect gas is an example of this adiabatic process. Next, types of processes, that is path, the series of states that through which a system passes during a process. To describe the process completely, one should specify the initial and final states as well as the path it follows and the interaction with the surroundings. Quasi-static or quasi-equilibrium process, when a process proceeds in such a manner that the system remains infinitesimally close to an equilibrium state at all the times. See here. So when a process is changes series of from state 1 to the state 2, the path it is opting is called the process path. Properties of a system. One is state. Specification necessary to define the conditions of a given system is called a state. Example, pressure, volume, temperature. Property. Variables used to define the state is called a state function or property of function. Homogeneous system with a single substance, that is pressure and volume and temperature. Any of these three properties depends on other two. If temperature and pressure are specified, all other physical properties like rho, u, mu, ri are definitely fixed. So thermodynamic properties serve to define state of system completely. Next, extensive property depends on quantity of matter specified in the system. Example, mass, volume, length, shape, heat, capacity. Total value of any extensive property is a sum of values of properties of individual components into which system can be subdivided. Intensive property, independent of size of the system. Example, pressure, temperature, specific volume, specific heat, density. As the intensive properties are independent of amount of substance, they describe specific characteristics of a substance in a given state. So these are the self-assessment questions and the terminal questions based on the closed and open system. Thank you.